Good evening, everyone. Good evening, friends. Welcome back to our day 15 of Python for AI session. So, what is the last topic that we have covered in the previous session? We started with operators, right? So, what exactly is operator? Operator means it's a symbol. It is a symbol which helps us to perform certain operations. Then, what is an expression? What do you mean by expression in Python? Operators is what we have discussed. Yes, good. These operators are nothing but symbols and they help us to perform certain operations. And when we have two or more variables or objects, if they are connected using these operators, then we call it as an expression. It is called as an expression, right? So what are the different operators we have in Python? In Python, there are in total 7 types of operators. They are arithmetic, assignment, relational, logical, membership, identity, and bitwise operators. Right? And in the last session, we have covered all the first 4 operators. Arithmetic, assignment, relational, and logical operators were being covered, guys. Right? Yes. So what is the purpose of arithmetic operators? What is the purpose of arithmetic operators? An arithmetic operator helps us to perform arithmetic calculations. Where we have addition, subtraction, multiplication, division, floor division, then modulus, and finally power or exponent. Everyone have to respond in the chat. Don't sit idle. Then, addition operator, it returns a sum of the numbers. Then subtraction operator will return as the difference of the values. Multiplication operator will return as the product. Division operator will return as the coefficient. And a division operator will always return as float. Float value as an output. Good. Then what is double slash? Floor division. The floor value will be returned once after we get the division performed. Right? Then the next operator which we represent using percentage, this is modulus, which returns as remainder. And finally, double star represents power operator. Clear? Good. Then next to arithmetic operators, we have discussed assignment operator. So what are the different assignment operators we have in Python? What are the different arithmetic operators we have in Python? We have only one assignment operator. It is equals to. It is equals to, not double is equals to. Is equals to is called an assignment operator. Okay, what is the purpose of assignment operator? The purpose of using an assignment operator is the right hand side value, whatever we have, gets assigned to left hand side variable or object. So that is the purpose of assignment operator. From day one we are using assignment operator without noticing. Okay. So whenever we want to assign a value to an object, we use assignment operator. And under assignment operator, we discussed two types. What are they? Single and multi-line assignment. Good. Good friends. Then next to assignment operators, we have discussed relational operators. So what are the different relational operators that we have in Python? We have greater than, less than, greater than equals to, less than or equals to, is equals to, and not is equals to. A relational operator helps us to compare the values. Okay, so here we have the 6 relational operators in Python, and a relational operator will always return as either true or false as output. Am I right? Good. Keep going. Then, next to relational operators, we also discuss logical operators. Good guys, good. So what is the purpose of using logical operators in Python? What is the purpose of using logical operators? Huh? So this is equals to and this is not is equals to. Exclamatory mark followed by is equals to is not equals to in Python. What we are combining? Logical operators, they help us to combine two or more relational operators. Okay, so when we have, especially when we have relational expressions, okay, so we can combine them using logical operators. Yes. So what are the different logical operators that we have in Python? We have and, we have or, and we also have not. We have not. So when does AND logical operator returns true? When does AND logical operator return true? Again, coming to the point, logical operators will return either true or false. Only these two values you can expect as output. So when does AND operator return true? When does OR operator return true? Do you remember the truth tables for AND and OR? Good. When all the relational expressions that we have, if they hold true, then if these relational expressions, if they are combined using AND operator, in that case, AND operator returns true. Okay. In short, an AND operator returns true when all the conditions, when all the expressions hold true. But when it comes to OR, if at least one statement, if at least one expression, if it is holding true, OR operator returns true. One is enough. Any one. Right? Good. So till here we have understood in the previous session, and we have also understood not operator. What is the purpose of not operator? Not logical operator. Good, good. Not operator helps us to reverse the output. So if our output is true, when we are using not operator, it is going to return as false. When the output is false, not operator will give us the output as true. In short, it is going to opposite the result. Reverse. Good. So I hope there are no questions with respect to all the four operators. And today, let us just continue with whatever we have stopped. Okay. So our agenda for today's session will be membership operators. The next operators that we have in the sequence are membership operators. Under membership operators, we have in, not in. So let us understand what exactly, the purpose of using membership operators. Okay. Then what are the syntaxes for in and not in operators? Right? Yes. So the next operators are membership operators. What is the purpose of using membership operators? The purpose of using membership operators is they help us to check, verify, okay, whether the existence of a specified value in an iterable object. What is an iterable object? Iterable object is nothing but an object which contains multiple values. An object which contains multiple or many values. Okay, like you remember all the data types? 14 types. They are categorized into 6 types, right? Apart from fundamental and none type, rest of the 4 categories, sequence, list, set and dict types, all these 4 categories under which we have again data types, right? So they help us to store multiple values. Yes. So that means, it is an iterable object. Iterable object is nothing but an object which contains multiple or many values. So the purpose of membership operator is, it helps us to verify or check the existence of a specified value. Okay, a value is present inside an iterable object or not. We can verify, we can check using membership operators. And in Python, we have 2 types. There are 2 types of membership operators. What are they? They are in and not in. In and not in. So let us understand the syntax for in and not in. In operator, the syntax is value in iterable object. Simple. Whatever the value that you want to check, the existence of the value that you are trying to check, value in iterable object. So this will be the syntax for in operator. And when it comes to not in operator, the syntax will be value not in iterable object. Okay, so whatever the value and the iterable object will be same, but only the membership operator is getting changed. If you are focusing on the syntax, only the membership operator is getting changed, in getting replaced with not in. But what will be the output for membership operator? Again, a membership operator will return us either true or false. It returns as either true or false. That's it. Like how relational operators, logical operators, they return only true or false as the output. In the same way, a membership operator will return the same, either true or false. That's it. Okay. Now let us discuss how this in operator works. In operator under membership operators, it returns true when the value is present inside an iterable object. If suppose the value that you are going to check, the existence of the value that you are trying to check in this iterable object, if it is present inside the object, yes, our membership operator in will return true. What if the value is not present? It returns false. Simple. Value is present, it returns true. Value if it is not present, it returns false. Okay. The next operator that we have is not in. Not in acts quite opposite to in. Okay. When does not in operator returns true is when the value is not present inside the iterable object, then it returns true. If the value is present inside the iterable object, it returns false. So that is the difference between in and not in membership operators. But very simple, just we have to check the existence of the value, whether it is present in the iterable object or not. That's it. Simple. And a point to be noted is the output of membership operator will be either true or false. That's it. Clear? Shall we go for hands-on? Right. So let us start the hands-on. I'll launch Spider. And so all these topics were being done, friends. Right? So let me open membership operators. Right. So what are we doing in line number 2673? What are we doing in line number 2673? I'm trying to store Python, which is a sequence of characters. A group of characters I want to store. So which type will be used? Which type will be used? Obviously, str type will be used to store Python in an object S. So let me execute. So Python got stored in the variable S, in the object S. Okay. And the type is str. Type is str. Size is 6. In total, we have 6 characters. Right. So that is the reason that size is 6. I hope it's clear. Right. I want everyone to be active. And from here onwards, you have to respond, guys. Right. So let us start using membership operators. The first operator, it is in operator. What is the syntax for in operator? Value in iterable object. First of all, is S an iterable object? Yes, it is. Why? Which type it is going to use? It is using sequence category data type, str. So S is an iterable object. So do we have P in S? Do we have P in S or not? What will be the output for line number 2674? True or false? Come on, guys. Respond. The answer is true. I have P. See, in S I have P. I have P. So when I execute line number 2674, the output should be true. The output should be true. Simple. I'm using membership operator in. Okay. I'm just following the syntax. The syntax is value in iterable object. Now, respond for line number 2675. P in S. Should it be true again? What will be the output for line number 2675? The output will be false. Why it will be false? Why false? Because what value are we going to check? Is it capital P? No. I'm going to check the existence of P which is in lower case. It is in not upper case. So do we have P which is in lower case in Python in S? No. So that is the reason it will return false. Python is case sensitive language. So focus. Then output for line number 2676. T in S. T in S. Parallelly, I'll execute. By the time I execute, you have to give the answers. So for the previous case, it is false. Now tell me for this line. Do we have T in S? Yes, I have T in S. So the output should be true. Yes, it is true. Then 2677, the next line. NEUT in S. Next era Unitech. Our organization. Okay. Do we have NEUT in S? No. It is Python. And what value are you going to check? It is NEUT. Do we have? No. The output should be false. What about the next line? PYTH. Instead of just keeping true and false, it's better if you keep the line number, then the answer. I can understand. What is the output for line number 2678? Do we have PYTH? Yes, I have PYTH in S. The same case. So the output should be true. True. Good. Then HON. Do we have HON in S? Yes, I have HON. The same order, same case. So obviously, the output will be true again. Keep going. Don't stop. For the next line, 2680. PTN in S. P, T, and N. I have PTN, but do we have them in the sequence? No, I don't have PTN in the sequence. So what will be the output for line number 2680? No, 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 no. Will it be true? Just have a look. That's what I'm telling. See, I should have the characters of same case, but moreover, in the sequence, I have PTN, but are they in the same, in the same sequence? No. But if you go to the previous lines, PYTH, HON, in the sequence, I have them. So for that reason, we got true as the output. When it comes to PTN, it is not in the sequence. So it will return me false. NOH. NOH. Is it in the sequence? By default, we go from left to right, right? So, do we have NOH in the sequence of, in the iterable object S? No, I don't have. So, this will also return false. But what will be the output for line number 2682? 2682. NOH in S of colon minus 1. What is this colon minus 1? What exactly the syntax that you see here? What is this? Which concept? Which concept to this belongs to? This belongs to the concept of slicing. Do you remember slicing? What do you mean by slicing? Slicing means obtaining a group of characters, a group of values, A range of characters is nothing but slicing. Right? So what are we trying to do? We are trying to get the iterable object in the reverse direction, in this direction. So NOHTYP will be the output for this particular part. For this part, the output will be NOHTYP. Now go and check. Do we have NOH? Yes, I have NOH. So what will be the output? The output will be true. So in this way, you have to use the concepts that we have discussed, guys. Okay. So practice multiple examples. Your fundamentals, if they are strong enough, you can work out on any question. So what is output? It is true. Are we done with the examples for membership operator? No. We have just completed the examples of membership operator on, STR type, sequence category. Now let us go to the next type. What are we doing in line number 2684? 2684. What is this? Within square braces, I have 10, then row sum in quotations 45.67 and true. A bool value true. What exactly is this? It is we are making a list object, okay, where it holds multiple values. All of them are organized inside square braces, and each and every value, each and every element are comma separated. So this will create an list object and it gets stored in LST. Just focus. Have an eye on the variable explorer. The moment we execute, you are supposed to look at the console and variable explorer. The size is for all the 4 elements we have over here. Now, let us use membership operators on, list category data type. It's a list category object, right? So let us use membership operator on list category type. First of all, is it an iterable object? Yes, it is an iterable object. An object which contains many elements is an iterable object. So do we have multiple objects, multiple elements? Yes. Multiple values? Yes. So let us start using membership operators. 10 in LST. What will be the output? 10 in LST. What is LST? Our list object. So do we have 10 in LST? Yes, we have. So output for line number 2685 will be true. Simple. Then what is the output for next line? 2686. Row sum not in LST. Our father of Python. Do we have him in LST, our list object, or not? We have him. But what is the operator that we are using? We are using not in. So the output will be, what will be the output? False. Right? You are supposed to focus on the operator as well, friends. Not just checking the value. Whether the value is present in the iterable object or not, keeping it aside. Also focus on the operator that we are trying to use. I am using not in. If it is in, I'll get true. I'm using not in, right? Then, what is the output for next line? 2687. Sum in LST. Do we have an element called sum? Just hold on. Is this sum that you are trying to refer? That is what I am asking you guys. What will be the output for line number 2687? Sum in LST. Will it be true or false? 2687. The output will be false. Is there any element? Sum? No. So that is what the meaning for this line is this value an element present in this iterable object or not? No. So the output should be false. But I have some in LST of 1. What is this? This is called indexing. Do you guys remember the concept of indexing? Indexing. What do you mean by indexing? Indexing is nothing but accessing one value at a time. And what is the syntax? We use square braces. Inside the square braces, we have to pass the index number. Okay, the index number has to be passed of that object. Okay, so that is indexing. We are trying to use indexing. LST of 1 will refer to row sum. So in this object, do we have sum? Yes, I have. So what will be the output? The output will be true. So that is the difference between the previous line and the current line. Here we are trying to check whether the element is part of this entire object. But here we are just trying to check whether this element or the value is part of LST object element 1, index element 1, only this particular element. That is the difference. So 2688 will return as true. Focus. Just focus. Right. Now this time you guys have to answer. What are we doing in line number next line? 2690. 2690. What is the object that it is going to build? All elements are comma separated. Good. And I see no duplicates. All the elements are organized in flower braces, curly braces. Right? So it is going to create a set object. Perfect, guys. And where did we store? We stored in S1, variable S1. Size is 7. So the output for line number 2691, 100 in S1. The output will be, what will be the output? Do we have 100 in S1? False. There is no 100 in S1. 10 in S1. Is there any value 10 in S1? Yes. At this position, I have 10. So there is an element 10 in S1. So the output should be true. 100 not in S1. 2693. 100 not in S1. Yes, I don't have 100 in S1. So the output should be true. Python not in S1. Sorry, I have Python. So what should be the output? Python not in S1, 2694. Don't we have Python in S1? Object S1? Should it be false or true? Whenever you're giving your answers, ensure that you're also cross-checking the case. Is this Python and this Python both are same? No, they are not same. So I don't have the Python which is in lowercase in S1. It is not in S1. So the output should be true. This is different, friends. This is in proper case. This is not in proper case. This is in lower case. Both are not same. Then Python not in S1. The Python that I want to check is it is in proper case. I have it. I have the same Python in S1. So this will return me false. The difference. Ensure that you also cross check your case. The case has to be cross checked. The Python that we have in line number 2694 and the Python that we have in the object S1 both are not same. That is the reason we got true. But the Python that we have in line number 2695 and the Python that we have in object S1 both are same. Even if you just focus, it is just highlighting only these two on the screen. Right? Now, next to it, let us go and create one more object, but I see the data is in key and value. How the data is organized? In the form of key and value. 10 colon apple, 20 colon mango. So what kind of value it is? I mean, which object it is going to form? It's a dict object. It's a dict object, friends. Okay, right. And the size of the dict object is 2. 10 in D. Do we have 10 in D? Yes. I have 10 in D. So the output should be true. 20 in D. Yeah, I also have 20. So the output should be true again. 100 not in D. Do we have 100? No. So 100 is not in D. The output should be true. I don't have 100. 10 not in D. No, I have 10. So the output should be false. Clear so far? The keys that we have are only 10 and 20. I'm trying to use in and not in both the operators. On the dict object, we are trying to use both the operators, right? Now, let me start, checking the values. The keys were being done. Now let me check values. Can we directly check the values? Let us check. Apple in D. Do we have apple in D? What will be the output? 2702. No. The output will be false. Very important. The why I am teaching n number of examples is, in and not in operators, they change with respect to different objects. Okay, especially when you are trying to use in and not in membership operators on dict object. Okay, and you can directly check the presence of keys in this fashion. But when you want to check the presence of value, okay, when you go in the same fashion, you'll get the output as false. Why? How can we access the values in a dict object? From a dict object, how can we access the values? Via keys. Via keys. So print of D of 10 will return apple. In order to access apple, I can access only via its key 10. So D of 10 will return as apple. Making sense? Okay, so now I'll use it. I can access the values via its keys. Respond for line number 2704. APP in D of 10. So what does D of 10 will return as? It will return as apple. So do we have APP in apple? What will be the output? 2704. The output will be true. I have right APP. For the next line, 2705. PPA in D of 10 of this is indexing. This is indexing. But here in the next line, we are using both indexing and slicing together. D of 10 will return as apple. Then on this, output, what are we doing? We are performing slicing. So we say that colon minus 1. So that means this entire value will be reversed. E, L, P, P, A will be the output for this particular portion. Right? So now check. PPA in ELLPPA. Yes, I have the value in the iterable object. Okay, so this will return as true. For line number 2705, the output will be true. What will be the output for line number 2706? Line number 2706. Obviously false. PPA not in the same. I'm using the same value, same iterable object, but just changed the membership operator. Here we got true. Obviously, here we should get false. It is present, right? So, for not in operator, it will return as false. What about line number 2707? 2707. APP not in the same, D of 10 colon minus 1. Do we have APP here? No, it is not APP, it is PPA. So the output should be true. I don't have, right? Okay, so now let me execute all the lines one by one. So for this line, I should get the output as true. For the next line, I should get the output as false. And for the last line, the output should be true again. Clear? Right. Now let us jump into the new operators. The next operator that we have are identity operator. So let us discuss the purpose of using identity operator. Then we also have two types under identity operators. What are they? We'll understand guys. Right? So let us understand the purpose of identity operators. Identity operators, they help us to compare. They help us to compare the memory address of two objects. So within the memory, in the main memory, each and every object, each and every variable will be stored, right? So under each and every object which is getting stored in the memory will have an address. How can we access the address of an object? Using ID function. Using ID function. I'll use ID function and I'll get the address of an element, address of an object. So identity operator helps us to compare the memory address of two objects, two variables. So what are the different identity operators that we have? We have is identity operator and is not as identity operators. And the membership we have in, not in. Don't get confused. Majority of the people, they get confused here. Membership, you are checking the presence, the existence. So the operators will be in, not in. But when it comes to identity, we are comparing the memory addresses. So the operators will be is not, is not. But you see the syntax? The syntax is same. Object 1 is object 2 or variable 1 is variable 2. For is not, object 1 is not object 2 or variable 1 is not object 2. Either I can refer it as variable or object, whatever it might be. Okay, I'm just trying to make you guys to understand the syntax of both is and is not operators. Making sense? Right. Now let us understand what will be the output for identity operators. When it comes to the output of identity operators, again we'll get true or false as an output for identity operators. So it might be relational operator or logical operator or membership operator or even identity operator. The output will be true or false. That's it. Then coming to the point, when does is operator return true? When does is operator return true? When both the objects, if they point to the same address in the memory, our is object will return true. Then when does is operator return false? If the both objects, if they don't refer to, if they don't point to the same address, then the output will be false. Same address, true. Different memory address, output will be false. Then is quite opposite to is. Is not operator will return true when both the objects point to different address, and is not operator will return false when both the objects point to same address. That is the difference. So if you remember one, obviously it is a complementary. The other operator, you'll get it as a complementary, right? I hope it is very easy to understand, because the purpose of identity operators is to compare the memory address of two objects. And how many how many identity operators we have in Python? There are two. They are is not. Even the syntax is very simple, friends. Object 1 is object 2. Object 1 is not object 2. So if the same address for both the objects, here I'll get true. If different address, I'll get false when I use is operator. When I use is not operator, if both the objects have different address, I'll get true. And if they have same address, I'll get false. Clear? So let us keep the same theory part on hands-on. Okay, I'll try to use different types of objects. Okay, all the possible types we are trying to use And this is one of the important concept under operators, because the examples that we have for identity operators are very huge. Okay, where we are trying to use identity operators on all the possible objects, on all, not even leaving a single one. So let us get started. Right. I hope no questions. Right. So what are we doing in line number 2712? I'm trying to store none. Yes. In an object A. Right. See, I'm going to store none in object A. Then the same none object is what I'm trying to store, same none keyword. Right. So I'm going to store same none in the object B as well. Just have a look. Which type they belong to? They belong to none type. So under the 14 types, one of the type we have it as none type. So both of the objects A and B, they belong to none type objects because they hold none as the element, none as the value. Clear? Then what are we doing in the next line? I'm going to use print function to print the value that is present in A, then type of A, that is data type. Then along with the type, I want to get the address ID of A. So this will result me all the three. So we have none and it belongs to none type, and this is where I have object A in the memory. In the main memory, I have object A stored at this location, at this address. Now, let me do the same for the next line. I'm going to print B, then the type and ID, address. So even this is also written the same. Yes, the same address is what it returns. Why? Because, within the script, we can have none objects as only a singleton. Whatever the none that we are using, they belong to singleton objects. So we can have only one, and what are the objects that we are trying to use to store none will be pointed to the same address. If you compare, if you just have a look, the address for both A and B is same. Now, if I keep it as A is B, what kind of operator it is? Identity operator? Yes. Is operator will help us to, you know, check, compare the address of both the objects. So what will be the output for line number 2716? 2716. The output. Obviously true. Why? The address is same, guys. The output will be true. Then what will be the output for the next line? A is not B. The output will be false. Is A? A is not B? No. The addresses are same. Right? So the output will be false. Clear? Right. So we have tried identity operators on none type. Now let us go and use it on dict type. Can you go for a wild guess? What are we doing here? I'm creating two dict type objects, D1 and D2, in which the elements, both key value pairs, both are same. You see, under D1, D2, we have two key value pairs. Okay. And these key value pairs are same. Are they different? No, they are same. Now, I'm trying to print D1 type of D1 and ID of D1. So this will return me an address where D1 got stored in the memory, and obviously the type will be dict. But what will be the address of D2? Will it be same of D1? What do you think of? What will be the address of object D2? Will it be same? Will it be different? Let me execute. Is it same or different? It will not be same. Even though if the key value pairs are same, when you are trying to build dict type objects, obviously it will store them at different locations in the memory. I can understand it from here. I can clearly understand the position, the address, the locations of the same D1 and D2 are not same. So D1 is D2. What will be the output? D1 is D2. True or false? Are they sharing the same location, same address? Obviously false. Because they are not sharing the same address. D1 is not D2. True. Clear? Then let me keep going, keep going. Let us use identity operators on, set objects. I'll just give 1 minute of time. Can you give me the output for line number 2730 and 2731? Where we are trying to use identity operators on two set objects S1 and S2. Okay. So what will be the output for line number 2730 and 2731? So let me create the set objects first of all. Done. This is also done. So let me show you the both. We have two set objects S1 and S2, but you see both of these two set objects have same elements, same values. What do you see? Are these both objects stored at the same location? Perfect. Perfect, friends. They don't get stored at the same location. Okay, so let me execute. So when I print S1, type of S1 and ID of S1, I'll get values, I'll get an address at which S1 got stored in the location, in the memory. In the same way, I'm trying to print S2, type of S2 and ID of S2. Are the address, are the location same? No, they are not same. Right? So what do you understand from it? I understand that the set objects, even though if the data, even though if the values or the elements, if they are same across the objects, still the address will not be seen. In the memory, it creates two different objects. S1 will be an object in the memory and S2 will be an object in the memory at different locations. That is what I understand from here. Okay, we are not just running casually. There is a, statement that has to be drawn. What we have to draw? It is S1 is getting stored at this particular location and S2 is getting stored at this particular location. So even though if the values, if the elements are same, still it is creating The two elements, two objects at two different positions, right? So let me use identity operator is, it will return false. Why? The addresses are different. If I use is not, it will be true. Clear? Perfect. Now, let us do it on frozen sets. Frozen sets. What are we doing? I'm taking the same S1 and S2 objects, set objects, and converting them to frozen set objects. I'm using frozen set function where a set object will be converted to frozen set object. So this is going to return as two frozen set objects, fs1, fs2. So what is your answers? Like, will the address of these two frozen set objects will be same in the memory or not? Will it be same? The address. Good. It is again the same in the sense, even for the frozen set objects, let us get the addresses. Do you find the same address? No, the address is not same. The address is not same. Okay. So in the memory, I see two different addresses for two different objects, but still the data is same. I mean, the values, the elements are same, right? So in the memory, it have created two objects, fs1 and fs2 at two different locations. So if I use identity operator is, it will return me false. If I replace it with is not, I'll get true. Now, in the next case, let us go to the next category, list category data types, under which we have two, list type and tuple type. So what are we doing in the next case? What are we doing in the next case? We are building list type values. We are coming with tuple type objects, tuple objects. My bad. So two tuple objects T1 and T2 gets created in the memory. They get stored. The values like 10, NEUT, 34.56. These values are same, the elements are same across the two objects T1 and T2. What is your conclusion? Will these two objects T1 and T2 get stored in the same location, same address? Come on guys. I'm going to create two tuple objects. Okay, that's fine. But do you think both these tuple objects get stored in the same address just because of holding the same elements? What do you see? No, different address. In the memory, it creates T1 and T2 at two different addresses. So let me get the output for 2742 and 2743. Are the address same? No. If the address is same, is identity operator will return as false. Is not will return as true. Perfect, perfect. Keep going. Everyone has to participate actively. Only then you will be learning, guys. Right. So once if I'm done with tuple objects, in the next case, what are we doing? What are we doing in the next case? Excuse me. We are coming up with two list objects in which we have 12 and row sum as the elements. L1 and L2 both are two list objects in which the elements, the values are same. They are same. Then what do you guess? Will these two objects L1 and L2, will they be stored at the same location, same address? Go for a guess. Will they get stored in the same address or different address? Good. They get stored in the different address. So when I print the address of L1, I'll get a value, and in the same way when I print the address of L2, I'll get a different value. So are these two same? No, they belong to two different locations. So when I use identity operator is, it has to return as false. If I use is not identity operator, it will return as true. Clear? Then let us go to the next case. What are we doing? Guys, from here onwards, I want everyone to participate actively because it is a recap session of our fundamentals again, data types. I have promised you, right? Each and every type we are going to cover. Under identity operators, we have examples for each and every type. So what are we doing in 2754? Which type of object we are going to create? Under sequence category data types, there is a type called range. Okay, so what is the purpose of range data type? What is the purpose of range data type? I can understand by just looking at range, everyone, just keeping the answers as range, but I want the answer. What is the purpose of range data type? What did we discuss? What is the purpose of range data type? Hmm? Range type helps us to store. Hmm, hmm, hmm. Not limits. No. They help us to store a sequence of values with a regular interval. Where is it? That is what I'm telling. The basics. Range type. We are using the second syntax. Start, end. Start, stop. 0. Okay. Till 9. We'll have totally 10 values, 10 elements getting stored when we execute line number 2754 in R1. What is the regular interval? By default, the step will be 1. So I'm going to create two objects R1, R2 of same range 0, comma 10, 0, comma 10. So what will be our answer? Will they get stored in the same address, same location? So you see two objects got created, S1, R1 and R2. Okay. So now I'm going to execute line number 2756, where I'll get the ID of R1 and ID of R2. Will they get stored at the same location or different locations? At different locations only, my friends. So this is the address at which R1 got stored in the memory, and this is the address at which R2 got stored within the memory. So since the addresses are different, is operator will return as false. Is not will return as true. Simple. Then next to range, what are we doing? Let us use byte array. Byte array objects. Let us try identity operators on byte array objects. For that, I am creating tuple, a tuple object of size 4. And what is the purpose of byte array object? Byte array object, byte array type. The purpose of byte array type is to store positive integers ranging from 0 to 255. Right? So will it create a byte array object? Yes. I have all the elements, all the values between the range. So this will create me a byte array object and it gets stored at BA1. Sorry, I have to execute 2761 first. Then, did it create a byte array object? Yes. In the same way, I'm going to create one more byte array object BA2 using the same tuple. Done. Done. Now, tell me, will these two objects BA1 and BA2 will they get stored at the same address? Yes, to store positive integers ranging from 0 to 256. It's nothing but 0 to 255. Good. What are your observations? It is going to create two different objects. Okay, so let me get the addresses. See, so I have BA1 at this particular address and BA2 at this particular address. Okay, so when I use is identity operator, it will return as false and is not will return as true. Simple. Then let us try identity operators on bytes object. Okay, for that I'm going to come up with a tuple object of size 4 and converting this tuple into bytes using bytes function. Okay, so this is going to create an object B1 and the next one is going to create an object B2. So is it going to create two different objects in the memory or only one? Will we have both the objects B1 and B2 pointing to the same address or a different address? Again, a different address only. For understanding, I'm going to get the ID of B1 and B2. You see, this is the address of B1 and this is the address of B2. So when I use is identity operator, it will return as false. If I use is not, it will return as true. So far, whatever the game, the movie, it went well. But from here onwards, your attention will play a crucial role because I'm changing the type. To which type are we going to use? What is the next case? We tried on dict, then we tried on set category types, then we also tried on list category types. Now we are trying it on sequence category in which we completed range, byte array, bytes. The only type that was left in sequence category is str. So let us also complete str, where I'm going to store Python in S1 and Python in S2. Done. So what happens or what will be the address of S1 and S2? Will they point to different or same? Will they point to the same address or different address? How many of you say different? Keep going. Okay, so all of my friends say is different. Let me execute it and you are supposed to focus on the console. So this is the address at which object S1 got stored and next to it, this is the address at which S2 got stored. S1, S2. Excuse me. What do you interpret from it? What do you understand from it? Are they different or same? So that is why Python is fun. So far, it went well smooth. In all the cases that we have tried, the objects got created at different locations. Am I right? Okay. So what are we doing here? I'm just working on identity operators. I'm going to use identity operators, but on str type data, I can understand that, when I try to store Python in two different objects, S1 and S2, they got stored. They're pointing to the same location in the memory. Both S1 and S2, they point to the same location within the memory. So this address, is what we have here. So when I use is operator, it will return me true. And when I use is not operator, it will return me false. It will return me false. Then what are we doing in the next line? I'm going to store Python, one more Python, but the Python that we have here and the Python that we have here, both are same? No. This is uppercase Python, lowercase Python. So obviously, S3 address will be somewhere different. In the memory, it will be different. Okay. So is S1 is S3. Here it will be false. Here it will be true. Okay. So anyhow, let me execute and I am done till here, right? So let me create one more object, S3, in which I'm going to store Python in lowercase. Then I'm going to print S3, the type and the ID. The address that we have here and the address that we got now, are they both same? No. No. So obviously, S1 is S2. Yes, the output should be true. Why? Because they are in the same location. They have same address. S1 is not S2. False. S1 is not S3. True. Why? Different location. S1 is S3. False. Clear? Simple, guys. If two objects they have same address, is operator returns true. Is not operator returns false. Okay. So why it has same and why it did not have same address, we have understood. Uppercase Python, lowercase Python. Now, let me try on a different example. I'll take str type data only, okay, where I'm going to store a sentence. There are two sentences. Python is an OOPS language, and Python is also functional programming language. So this is what the str, the sequence of characters that we have, and I'm storing this inside an object S1. And if you see the same characters, we are going to store in S2 as well. So let me execute S1, line number 2788 and 2789 got stored. The same, even the size is same, the type is same, but two objects is what I'm trying to use. Right. Now tell me, will these two S1 and S2 have same address in the location in the memory? Within the memory, will they have same address or different address? How many of you say yes? Very important. This is very important. That is the reason why I'm taking more time. Will it take same address or different address? Good, good. Active participation. Right. So the answer is different address. It is different address. Why? Here I try to store Python, okay, and the type that was used is str. I'm trying to use the same type to store my sequence of values. How come it will be different? But in the previous case it is same, right? Now why it is different? We'll understand. Let me execute first of all. So this is the value that got printed and this is the address of S1. Then let me also get the location of S2. You get the same location in both the cases? No. Why it is playing with us? Is it same? No, it is different. This is just because of, there is a concept called interning. Okay, especially str type data, the objects that we create, if they are small, like Python, okay, the same address will be used. For the objects, the same address will be used as a concept of memory optimization. Very important, guys. Why identity operators are very important, we can work out on all the possible types and they do not work in a similar manner. Okay. So there is a concept called memory optimization. Within the memory, the small str objects like Python, your names, whatever it might be, the same location within the memory, the same location will be used for the objects like Python. But is this a small one? No, it's not a small, uh, str object. You see the size of the object is 51. So it has created two different locations for the objects. So S1 is here probably, S2 is here in the memory. When the addresses change, is operator false, is not operator true. Clear? Very important. Under str type, especially we have the concept of interning. Okay, so this comes under memory optimization. In order to optimize the memory, only for the small str objects, str type objects, it uses the same location for the objects. But for the big str objects, it is going to create different locations in the memory. Different addresses will be used. Let me execute both the lines. 2792, it is false. 2793, it will be true. Clear? Is it clear, guys? Now, we are done with all the types apart from fundamental category data types. Let us start working on fundamental category data types. I'll use fundamental category data types, okay, on which I'm going to use identity operators. So what I'm trying to do, I'm taking complex type value, okay, 2 plus 3j, A plus bj format, and I'm storing in A the same complex value I'm storing in B. A, B will have the same value, the same type will be used to store in the memory. So what do you think? Will the address of these two objects A and B will be the same or different? Will it be same or different? How many of you say it will be same? Will the address be same? No, the address will not be same. Let me execute. It will be different. Have a look. Okay. Even though if the values are very small, but still, for each and every complex value, in the memory, it will create the objects at different locations. So A is B will return as false. A is not B will return as true. Different addresses will be used to store the same value. Even if it is same value in the memory, for A it will have a different address and for B the address will be different. Simple. Right. Then let us work on bool type. What is the value that we are going to store? We are going to store value true in object B1 and in B2 also I am going to store true. So what will be your answer for the bool type? Will the same address be used or a different address? Just go for a guess. Will it be same address or different address? Keep going, keep going. The answer will be same address. It will not be different. Why? Because in a Python program, true, false are singleton objects. Okay. So you can have only these true, false as singleton objects. And the values that the objects that you are trying to use to store these will point to the same location. You see, the location, the address for B1 and the location for B2, are they same? Yes, they are same. So the output will be, for is operator, it will be true. For is not operator, it will be false. Keep going. Now, let me do it on a float value, a float type value, 3.4. So what do you think? Will it use the same address to store the objects A and B where the value is 3.4? Will the same address be used to store A and B? Because the value is 3.4, right? The location, the address in the memory for A and B, will it be same or different? It will be different. Let me execute. Have a look, friends. So this is the address for A and this is the address for B. Okay. So even though the value is small, 3.4, but for float type values, okay, for each and every value, it is going to create a new address. The object gets stored at different address. So is operator will return as false and is not will return as true. Then the fundamental category data types under which we have covered three, where the last one it is int type. Okay, focus. What are we trying to do? I am trying to store 100 in A and the same 100 in B. Okay, I'm trying to store an int type value 100 in A and B. So what will be the output for line number 2818? Will the address of A and B, will it be different or same? Will the address of A and B, will it be same or different? Come on friends, make it up. Different address? Okay, let me execute. Is it different address? Focus. Same address. Same address will be used. Okay. So especially under int type values, okay, if the values are small, as a part of memory optimization, the objects will be located to the same address. They'll be pointing to the same address. Okay. So A is B will return as true. A is not B will return as false. In the same way, can you guess for the next example? Where I am trying to store 256 in A and 256 in B. So will the output be same again? Will they point to the same location? Obviously, the value is small, right? That is what we have discussed here. So the address of A, sorry, this has to be A. So the address of A and the address of B, are they both same? Yes. They are pointing to the same address. So is operator will return true and is not operator will return false. Let me go beyond it. Let me take 257. What happens if I take 257? Let me store 257 in A and B. Will address of A and B same still? the address changes here. The address will be different. It will not be same address, guys. The address will change. Why? Till 256 it is accepting, right? Let us understand. No issues, let us understand. Instead of taking a big number, I take a small int value, -2. -2, where I am trying to store -2 in A and -2 in B, and I am trying to get the address of A and address of B. What's happening? Again, they are pointing to the same location. So A is B will return as true. A is not B will return as false. No, 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 no. It is not from 0 to 255. I'll let you know. This was already covered, but anyhow. Let me store -5 in both the objects A and B. ID of A, I got a number. ID of B, again, the same number. So that means even if I try to store -5 in the objects, it is getting stored in the same location. Okay, both the objects A and B, they are pointing to the same location. Let me go beyond it. Where I'm trying to store -6 in A and -6 in B and trying to get address of A and B. Do they have same address? They don't have same address. No. So A is B will return as false. A is not B will return as true. So what we have to understand from here is, especially in int, under int type, okay, between the values of -5 till 255. Okay, so between the values from -5 to 255, it again uses the same memory, the same concept, memory optimization. What happens is, these values, they are considered as small values. And because of these values being small, within the memory, if you are trying to store these values to the objects, whatever might be the object, if you say A, if you are trying to store -5 in A and even -5 in B, they point to the same address. Why? Because they belong to the small values. But if you go beyond it, in this case, they are pointing to different location in the address. So A will be here, somewhere B will be here. If I'm trying to store -6. Even if you store 256, if you're going beyond the range, the same. But if you try to take any number from -5 to 255, okay, if you're trying to store the value for the object, it uses the same location for the objects. The same address will be given to the objects. The only reason is they are treated as small values, small int values. I hope it's clear. Okay, so whatever we have discussed, we'll quickly recap with respect to identity operators. Okay, so let us quickly recap. Identity. What is the purpose of identity operators? They help us to compare what? Memory address. So within the memory, each and every object will have an address. Okay, in the main memory, the object should be stored at a location, the address. So in order to compare these addresses, we use identity operators. What are the two identity operators we have? Is and is not. And we have tried is and is not on all the possible different types of data. Okay. So on all the 14 types, we tried. And where we have the special cases, we have the special cases in none, bool, str, and int. Under none and bool, these are treated as singleton objects. That means we can have only one value in our Python program. It might be true, false, or none. Okay, even though if you are trying to store true in multiple objects, they point to the same address. Then coming to str, if your data, if your sequence of values, if it is small, str interning will be done as a part of memory optimization. Okay. So in that case, we'll get true. They point to the same location. But if the str object that we are trying to store, if it has big value, big range of values, characters, then they don't point to the same location. And under int, between the range of -5 to 255, the values point to the same location. The objects point to the same location. If you are trying to store any of the value between -5 to 255, beyond this range, even the addresses change. They point to different locations. So these are the special, out of all the types, all the 14 types, we have 4 types that has to be pointed. Okay, we have to focus on these 4 types in which the memory address will be same, especially in these cases. But when it comes to other 10 types, it might be dict, tuple, frozen set, list, set, byte array, bytes, range. In all these cases, complex, then even float. In all these 10 cases, even if you are trying to store the same value in the memory, different objects get created. Different objects get created. Is it clear? Right. So that's all for the day. And if you have any questions, you can shoot your questions. And before that, if you feel that the session went well, hit on the like button, friends. It's a kind of encouragement that we get from your side. And also, we are asking you guys to share across your connections. Ask them to learn Python. Okay, learn Python because this is one of the primary skill in job market, right? So do post across your connections. Ask them to learn Python, and as well as when you're doing hands-on, if you face any kind of exceptions, errors, just post them in the comment section. We'll respond immediately. Right. Thank you. Thank you so much. So we have also posted the feedback link. Ensure that each and everyone give you a valuable feedback. Thank you so much, guys, for making the session interactive. Right. Thank you so much for joining and making the session interactive.